Hello students, let me tell you, today we are going to discuss the chapter Work, Power and Energy. Before we start this session, let me introduce myself. I am Krishnamurthy Madhusudan. I am a postgraduate engineer. I have been teaching board syllabus entrance exam preparations for more than 20 years. So students, during the course of my session, I will be giving you tips how exactly you need to make a strategy for the entrance preparation as well as for the board preparation. Most of the students have this idea in mind that entrance preparation is different and the board preparation is different. They are subset of each other. Let us assume that and let us start with it. Now, before we go into the chapter of Work, Power, Energy, I expect that you are keeping yourself very safe in this present situation. Moreover, you are judiciously utilizing the time, as the kind of time which is available to you right now will not be available to any other batch. The reason is, you will have your college, once it begins, then the study time will reduce and hence your preparation will change. But right now, let us judiciously utilize the time. How? Please understand words one by one. Work. Let us say work. Now, what is the meaning of work done? When we say work is being done, this is an effect of the force. Force, when acts on a body, that force can bring about many effects. One of the effect is bending, buckling, what you call as elongation, or it can cause displacement in the body. Now, in case of work done, we are interested in that effect of the force in which a body gets displaced from one point to another point. So, the force and the displacement which is obtained by the application of the force measures the work done by the force. As a diagram, see, if I say that a body is there, this block is placed on a surface, smooth surface, let us consider. Now a force is applied on it. This is the force which is applied on it. The applied force is at some angle theta to the horizontal. Now when the applied force is at some angle, what will happen to the body? This body will start getting displaced, and let us say it comes to this position. This is the new position taken by the body. Now this is the displacement in the body because of the application of the force. Now this force F can be resolved into two components. This force F, we can resolve it into two components. This is one component which we call as F cos theta. This is another component which is F sin theta. Now the displacement S and F cos theta, they are in the same direction. So how much will be the work done? So the work done is measured as the product of the force and F cos theta and S. This we can write as F S cos theta. This is what we can write. Now in the language of vectors, we can write this as F dot product with S. Now the question arises, what is the meaning of this dot product? What exactly is the inference we draw from the dot product? So dot product, why dot product only? Why not cross product? The reason is, work done is a scalar quantity. Therefore, force, which is a vector, displacement is also a vector quantity, but the result that I want is a scalar quantity. That is why we say work done is dot product of force and displacement. Observe, f cos theta we have taken, although f is acting this way at an angle, but f cos theta is acting in the direction of displacement. That is why we define work done as product of force and the distance traveled by the body in the direction of the applied force. So when we say in the direction of the applied force, that is exactly what is in language of vector displacement. So we have f dot s. Now the question is, what will be the unit of measurement? How to measure it? So work done, if I say unit will be, SI unit is joules. How it is? Newton, because work done is what? We say Fs cos theta. So force is measured in newtons, displacement will be measured in meter. So this is exactly what gives us as the joules. Now what will be the dimensional formula of work? So the dimensional formula, if you see, work, force mLt minus 2. This is force and displacement is taken as L. So this comes out as mL square t minus 2. This is the dimensional formula of work done. So students, you are now aware of what is the dimensional formula of work done, what is the SI unit, CGS unit is ergs, joule is the SI unit, and we have it as a dot product. Now, how exactly we have to evaluate the dot product? So just to give you a brief of dot product, you have done this in vectors. Still, just to give you a brief of how to find dot product. Now, what exactly we mean by dot product? Let us say a vector is ax I cap and ay j cap. This is what we have, and az k cap. At this juncture, I expect that you know what exactly is the meaning of I cap, j cap and k cap. Similarly, b vector, if I take it as bxi plus byj plus bzk. This is what we have as two vectors, a vector and b vector. Now, a dot b. See, we are finding a dot b. When we try to find dot product, that is a dot b, how exactly we have to find it? See, this is ax I cap plus, first of all, we need to know how exactly dot product is meant. The dot product can also be said as magnitude of A into magnitude of B into cos of angle between them. This theta is the angle between vector A and vector B. That is exactly what is the angle theta. Now, A dot B, magnitude of A, this is magnitude of B, and theta is the angle between the vector A and B, right? Now, also we can write A dot b as, see, it is given in vector form, so we will write it as ax I cap plus ay j cap plus az k cap. This is a vector, and then we have a dot, and then b vector is bxi plus byj plus bzk. This is what we have as a dot b. When we pass on the values of a vector and b vector, now the next step is apply distributive property. Open up the brackets. When we open up the bracket, what I get is ax is a scalar quantity, bx is a scalar quantity, and I will have I dot I. This is what we get, plus ax by I dot j plus ax bz I dot k. This is what we get with ax. Now proceed with ay. Similarly, we will get plus ay bx j dot I plus ay by j dot j plus ay bz j dot k. This is what we get with ay. Now az is also there, na? Plus az bx k dot I plus az by k dot j plus az bz and finally k dot k. Students, for your benefit I am saying this, please expand like this yourself, write it and practice. That would be the best way of understanding things. Next step is, how much is this I dot I? How much is I dot j? These dot products, how much will be that? To find this particular thing, see what we can write. I dot I, observe this, I dot I. Use this formula. Use this. I dot I is magnitude of I into magnitude of I into cos of angle between them. How much will be the angle between I cap and I cap? What do I cap represent? It represents the unit vector along positive x-axis. Another I cap is unit vector along the positive x-axis. So the angle between them will be 0 degree. They are parallel. So cos 0 degree. So what we get? Magnitude of I, unit vector is 1. This is also 1. Cos 0 is 1. So what we can conclude? I dot I is 1. So what exactly we can infer from this? Dot product between two similar vectors is 1. Similarly, I can say j dot j is 1. Similarly, k dot k is 1. Fine. Now what if the vectors are dissimilar? Dissimilar means I dot j. This will be how much? I dot j. This is magnitude of I into magnitude of j. Now what is I cap? Is a unit vector along positive x-axis. J cap is a unit vector along positive y-axis. So what is the angle between them? 90 degrees. Very right. Cos 90 is how much? 0. So what we get? So I dot j is 0. This means dissimilar vectors, if we take dot product, it becomes 0. If we use this information if we use this information that I dot I is 1, I dot j is 0, so this cancels out, I dot k is also 0, this cancels out, j dot I is 0, this cancels out, j dot j is 1, this also cancels out. See? So what is left out? What is left out is a dot b works out as ax bx plus ay by plus az bz. See, observe a dot b, what we are getting, ax bx, is there a unit vector with this term? No. Ay by, is there a unit vector with it? No. Az bz, is there a unit vector? No. This means the result of dot product is a scalar quantity, and that is why dot product is also known as scalar product. Is it clear? So this is the concept which we have to use in case of dot product. See how exactly we have to evaluate. Now suppose that A and B are perpendicular to each other. Suppose that A vector and B vector are perpendicular to each other, then the angle between them is 90 degrees. So cos 90 makes it 0. So the dot product is 0. So what we can conclude, if the dot product between two vectors is 0, this means that the two vectors are perpendicular to each other. Or vice versa, if two vectors are perpendicular to each other, then the dot product will be 0. Now, this is the basic thing that you must know, then only we can evaluate f dot s. This is exactly how we are using. Now, I will try to highlight this particular concept by taking some numericals which will highlight how to use the dot product. Clear? Now, let us solve this question. The question reads like this. Calculate the work done by the force F, which is given as, so force is given, force the vector quantity, that is given as 3i minus 2j plus 4k. This is what we get as force in vector form. Then in carrying a body from A to B, this means that the force, applied force F, is displacing the body from A, the coordinates are given, to B. Okay. So initial point A is given as, if you take it as point A is given as minus 2 meter. These are the coordinate. We can write it in the vector form. If you are aware of how to write in the vector form, we can write it as OA vector. This is minus 2i plus j minus 3k. This is in vector form the position of the point. It is also known as position vector. Then OB. OB is given as 3i plus 6j plus 2k. This is what we have. Now we have to calculate work done. Now, what will be work done? So, work done is F dot S. So, here, what is S? S is OB minus OA. Displacement, S is displacement, and if you have done this term, displacement in motion along a straight line. So displacement, final position minus initial position. So final position is OB minus OA. So 3, so this you will get as 5i. 6 minus 1, so plus 5j. This is 2, so this is 5k. This is exactly what we get for displacement. Also now W is F dot S. So dot product, F is how much? 3I minus 2J plus 4K dot 5I plus 5J plus 5K. This is what we have. Now how do you take? If you remember just now what we did, the dot product, 3, 5, 15. I dot I is 1. Minus 2 and 5. This is minus 10. 4 and 5 makes it 20. So this is how much? This is 25 joules. See, that is exactly how dot product. Please understand, this is a very important concept. This will be asked, this type of questions will be asked both in your board exams as well as in entrance exams. KCT also, very frequently such questions are asked. So dot product, please understand the dot product. This is exactly how we are supposed to take the dot product. Now one more question. Let us solve this question. The question reads like this. A person pushes a lawn mower through a distance of 20 meters. Students, to solve numericals in physics, the first step which is mandatory, which is required, is you have to record the data which is given in the question. Write it in the format that you can understand and that you are knowing. See here, it is given through a distance, so I will take it as S. This is 20 meters. This is what is given. If he applies a force of 200 Newton, so force is also given, 200 Newton. In a direction inclined at 60 degrees to the ground. Please observe the diagram. Possibly you will get an idea. Theta is given. So theta is given as 60 degrees. Find the work done by him. So we have to find work done. Work done will be how much? Now, how to proceed? Now we know that work done is F dot S, right? This is known to us. Now from the given data, try to convert this particular formula. Formula will be the same, but depending on data we have to transform it. So I can write this as F S cos theta. Why? Because F is given in the absolute value term, it is not given in unit vector format. Had it been given in terms of I cap, J cap and K cap, we would have done directly here, but it is not given in that format. So F is how much? 200 Newton. S is how much? 20. And cos of 60 degrees. Cos 60 is how much? Half. So what you will get? This as see, that is exactly how we can use this format. See how to use Fs cos theta, how to use F dot S. So this is exactly how work done is to be calculated when we have a constant force. This is the formula which is to be used for a constant force. Now the question arises, what happens if the force is a variable? So let us take that now. Now let us try to understand how to find work done by a variable force. Work done by a variable force. Now what is the meaning of variable force? Variable force means force is a function of some other quantity, that is called variable force. So suppose F, the force F is given as some function of distance. Force is given as some function of distance x. Now, small work dW will be f dx. If I take the displacement as dx, then f dx, because it is in the same direction, theta is 0 degree, cos 0 becomes 1, so we can write it as f dx. Therefore, total work done W will be integration of dW. When we say integration of dW, so we will write this as integration of f dx. This f is a function of fx. We will write whatever the function is given for force f. Now, there has to be a limit, because it will be given from work done from, say, the position x1 to x2. So your limits of integration will be from x1 to x2. This is exactly how we find out work done when the force is a variable. So students, as a key point to remember, just you can remember this as key points. Key points. First, you can write work done as fs cos theta, that is same as f dot product with s. This is first one. And the second, if it is a variable force, this is when the force is a constant one. So you have only two formulae to remember. Otherwise, W is integration from x1 to x2 of f dx. These are the only two formula which you will be using to calculate work done by any force in any situation. To help you understand how to use this integration, I am taking now one numerical based on this fact. Well students, let us take this question. The question reads like this. A force F, please record it, F is equal to 7 minus 2x plus 3x square. See here, force depends on distance x, that is what we had seen. Try to correlate. Force F acts on a body of mass 2 kg and displaces it from x is 0 to x is 5. So x1 is 0, x2 is 5 meter. Calculate the work done. Now, what is W? Because force W is equal to integration of f dx from x1 to x2. So what we will write this as? This is from x is 0 to 5. 7 minus 2x plus 3x square dx. This is what we get. Now we will use the rules of integration to evaluate each term. So what we get? This we will get as 7x. This we will get as x square. And this we will get as x cube. Because x square by 2 cancels out. X cube by 3 cancels out. Now how will you write the limits? Limits are this way, 0 to 5. How do you evaluate when the limits are given? Upper limit minus lower limit. So upper limit, so you will put it as 7 into 5, 35, minus 5 square, 5, 25, plus 5 cube, 125. So what we get this as? This is 10, so 135 joules. See, this is exactly how when the force is a variable, this is exactly how we are supposed to use. So students, to give you in gist the key points for work done, for this topic work done, you have only two things to remember. If the force is a constant force, then you can use Fs cos theta based on whether force is given in absolute terms. Use it as F dot S based on if force is given in the unit vector system. This is one way of finding work done if force is constant. Second is force can be a variable. If the force is variable, we will use the integration method. So this is exactly how work done can be calculated. Now to highlight this application of integration, I will take one more question. Well students, let us try this question. These type of questions are very common in KCET exams. The distance x covered by a body of mass 2 kg under the action of a force is related to the time t as x is equal to t square by 4. This is what is given. Find the work done by this force in 2 seconds. It says when t is 2 seconds, how much is the work done? Now, what is work done? Work done is force into displacement. We have x. Correct? Distance x. Force is what? M into A into x. A is the acceleration. So, here what we have? X is equal to t square by 4. So, therefore, V is equal to dx by dt. First derivative of distance, you get velocity. This is what? T by 2. Acceleration is dv by dt. So this gives you 1 by 2. So acceleration is 1 by 2. Now pass on the values here. M mass is given as 2 kg. So 2. Acceleration 1 by 2. X is what? This x comes from this. T square by 4. T is how much? 2. So 2 square by 4. So what we get this as? 1 joule. See how here, see, try to understand the kind of questions which are framed. The formula is same, but the way terms or data is given to us, that we have to understand. That is exactly how this question can be solved. Well students, let us try one more question. The question is this type. A force F is equal to A plus Bx acts on a particle in the x direction. Positive x direction because it is not given minus, where A and B are constants. Find the work done by this force during a displacement from x is 0 to x is t. How to approach this? First of all, record the data. F is given as A plus Bx. A and B are constant. So we can say that force is a variable force because it depends on x. So it's a variable force. It is not a constant force. So if it is a variable force, how do we find work done? W is from x1 to x2 of f dx. This is what we have as work done in case of variable force, correct? So substitute the values now. From x1 it is given 0 to d, and here we get a plus bx and dx. Now what is to be done? We have to integrate this. If you integrate, what you will get? Ax plus bx square by 2. This is what we get. Now the limits. The limits are from 0 to d. That's all. So if you pass on the limits, what you will get? You will get this as AD plus BD square by 2. Because lower limit is 0, it will become 0. This is exactly how we can find out work done when it is given in the variable form. Well students, let us take up this question. This is also a question which is very commonly asked in the entrance. A cluster of clouds at a height of 1000 meter above the earth burst and enough rain fell to cover an area of 10 power 6 square meters with a depth of 2 centimeter. Now let us record the data. It is given height is 1000 meter. Height is given. Then area is given. Area is given as 10 power 6 square meter. Depth is given, D is 2 centimeter. Please convert this particular thing into SI unit. So that is 2 into 10 power minus 2 meter. Now, how much work would have been done in raising water to the height of the clouds? To the height of 1000 meter. This is what is asked. Work done. See, work done is what? In this case, see, work done is Fs, right? Cos theta is, again we can take it as 1. Now here F is what? You are raising it against gravity, you are lifting it. So force, this force will become mg, and this is your h, height. So mass is what? Volume of water into density of water. Mass is volume into density into g into h. See how from the basic fundamental equation we are able to solve this question. Volume is what? Area of cross section. See, area and d into density into g into h. That's all. Always substitute the data in the end. Now I will substitute all the values which are known to us. Area is 10 power 6 and this d is 2 into 10 power minus 2. Density of water is 10 power 3 if you take in SI units. In CGS units it is 1 gram per centimeter cube. It is 10 power 3. Let us take G as 10 for our calculation purpose. If it is mentioned 9.8, please take it as 9.8. Height here is given as 10 power 3 1000. This is what we have. See, as simple as that. If you see the question, then it appears that the question is having many terms. It appears confusing. Absolutely no. Please try this. This is 3 and here also 3. So here 10 power minus 2 you have. So this gives you 3, 1, 2, 5 and 6, 11. So 2 into 10 power, we can say this is the kind of work which is being done. So students, first step to solve any numerical in physics is record the data which is given in the question in the proper mathematical form. These data in this question is given in an English statement form. Convert that into mathematical form. See. Next, second step, what is asked? Work done. So what is the relation here? See, go on converting. This is exactly how you can make solving the numericals in physics easier. That is exactly how we have work done by variable force and equation for work done. Well students, let us take one more numerical. The question reads like this: a particle moves from position R1. So from position R1, please try to understand the language. So the initial position is given. R1 is given as 3i plus 2j plus 6k meters. This is given as initial position. 2, so R2 is given final position. Final position is given 14i plus 13j plus 9k meters. This is what is given. Under the action of a force, so force is also given. Force is given as 4i plus j plus 3k. This is what is given. Find the work done. Well students, now you can decide which equation is to be used of the two. Here we see that the force is a constant force. Therefore, we will use the concept of F dot S. Why? Because force and the displacements are given in unit vector format. So now, work done is what? F dot S. So that is F dot S is what? R2 minus R1. This is exactly how we can find displacement S. So substituting the values, what we get? 4i plus j plus 3k and dot product. If you find the dot product, what you will get? 14 minus 3, this is 11i. 13 minus 2, 11j, and this is 3k. Now this is exactly how we can find. Now you can find the dot product. So the dot product, if you find, what you will get? 4 and this is 11, similar ones, na? So 44. This is 1 plus 11, this is 9. So this is 64. That is exactly how we can find out what exactly is the work done if the force is given in the constant format. Clear? Well, students, let us try this question. This is a very conceptual question. A particle of mass 0.5 kg travels in a straight line with velocity v is given as 5x power 3 by 2. Find the work done by the net force during its displacement from x is 0 to x is 2 meters. See, here this question is based on the concept of variable force. See, v depends on x, and here also displacement is given x is 0 to x is 2. So variable force, first of all let us try to record the data. It says mass m. Mass m is equal to 0.5 kg, this is given. Then it says velocity is given, so v is equal to 5x power 3 by 2. And then x1 is 0 and x2 is 2 meter. This is exactly what the data is given. Now, how will you approach? We can write dw is equal to f dx. This is what we can say. F, we can write it as m a dx. V is given. Now, see, now V is equal to 5x power 3 by 2. So we can find A. A will be what? dV by dt, right? So you can write this way, M. A is dV by dt and here dx. This is what we have. So dx by dt you can take it as V, and V is known, right? So this equation will come out as m v dv, because dx by dt, this dx by dt can be written as v. This is how we can simplify the given equation. Now v is this, differentiate it. So dv is equal to 5, this is 3 by 2 x power 1 by 2 dx. So this gives us 15 by 2 x power 1 by 2 dx. This is dv. We got dv, we got v. So what we can say, dw is equal to m, mass is 0.5 into v, v is 5 x power 3 by 2 into dv, dv is 15 by 2 x power 1 by 2 and dx. See how each of the term can be substituted. So what we get now, this is 75 and this is by 4 and x square dx. Single variable equation, all the variables now converted into a single variable, that is x. See, now we can integrate. So on integrating, now W is integration of dW. So that is 75 by 4 integration of x square dx. So the question arises, what is the limit? The limit of the integration is the displacement, which is given as from 0 to 2. So you will write this as from 0 to 2. So what we get this as? This you will get as 75 by 4. Integration of x square is x cube by 3 from 0 to 2. So what we get now on substituting the limits? Lower limit is 0, so upper limit is 2. So we get this as 75 by 4 into 8 by 3. Simplify this. This is that is exactly how we can evaluate such questions. This is a important conceptual questions. This type of questions are very frequently asked in the entrance exam, so you got to be prepared. So just understand this, how exactly we are moving here. First, see every question, every numerical in physics, I am trying by the same method. Record the data. We have dW because it is a case of variable force, so dW is F dx. F is m into a dx. A is dv by dt into dx. Now rearrange the terms, you got mv dv. This is from the rearrangement of the fundamental terms in the equation. Now it is given v is equal to 5 x power 3 by 2. So therefore what we have, differentiate both sides. dv is equal to 5, this is x power n x power n minus 1, we get this dx. So we got dv. Substitute now. That is exactly what the method we will be using to solve such questions which are pertaining to variable force and to find work done.